Hey kids, this is lesson 1, factoring the greatest common factor. This is our second video, and now we're going to actually get into the factoring. Before we were doing the expanding, reviewing that. So this says in the above practice, you use the distributive property to expand. You took factors and you express them as a product. This process is called expanding or simplifying. For example, 5x times x plus 3 is equal to 5x times x plus 5x times 3, which is 5x squared plus 15x. So this was factored form. Use the distributive property to get to expanded form. The inverse operation to expanding is factoring. So we're going to go from here, factoring, to here. So we're going to pull out the greatest common factor. We factor an algebraic expression by expressing it as a product of factors. This process is called factoring. For example, 2b squared minus 14b plus 24. So we're going to factor this. You might not understand how I'm going to do this, but I'm going to do it very quickly. So first of all, I know all three terms have a common factor of 2. So I'm going to pull out a 2, and my second factor would be b squared minus 7b plus 12. Then later on, you're going to learn how to factor this quadratic. This would factor to b minus 4 times b minus 3. So complete factored form is 2 times b minus 4 times b minus 3, and those are the three factors of this expanded form. So the operations of expanding and factoring are inverses. That is, they undo each other. So if we were to multiply this out, we would go right back to here. If we were to factor this, we would go right back to there. They undo each other. When we're asked to factor, you always factor out a greatest common factor first. This is a first step that is commonly missed. Always look for a greatest common factor first. And that's all we're going to do in this lesson. So I have the expression 8x squared y minus 12xy. And I'm looking for the largest term and number that divides into both of those terms. Well, 4 divides into 8 and 12. So that'll go into them. These terms share an x, so x would divide into both of them, and these terms share a y. So the greatest common factor of these two terms, which divides into both of them evenly, is 4xy. So I write each term as a product of the greatest common factor. So this term is equal to 4xy times 2x. If you multiplied those together, you would go right back to 8x squared y. This term is equal to 4xy times 3. If you multiply those together, you go right back to negative 12xy. So now we're going to use a distributive property to write as a product of factors. So if you notice, these two expressions share a 4xy. So that comes out, and you're left with 2x minus 3. If you were to multiply this back in, you would get the exact same expression that we started with. This is simply a check. This is not your answer. Your answer in factored form is right here. This is just a check that we did it right. When you multiply this back out, you get the factored form, or excuse me, the expanded form. So greatest common factor. You're most likely going to skip this step. You're going to go right from here to here. All right, so I want you to try to figure out what's the error shown here, and then we'll go over that next class, but you should have this done. What is the error? What is the common error? On the next page, you're going to be factoring these completely. I am going to do the first couple, and then you're going to do 6 through 11. 6 through 11. So I'm going to do 1, 2, 3, 4, 5, and 12. All right, here we go. Excuse me. So you always want to look for the greatest common factor. The largest number that divides into all three of these terms is 6. The largest number of x's I could pull out is x. They all share at least one x. And the largest number of y's I could pull out is a y squared. So I have to think of 6xy squared times what would give me this first term. So that would be 2y. If you multiply those two together, excuse me, it'd be 2xy, you would get that first term. Then I'm going to think 6xy squared times what gives me 18x to the 5th y squared, and that would be negative 3x cubed. If you multiply this and this, you get that. And then I'm doing the same. This times what gives me that? That would be y squared. So there is complete factored form. Then I would try to see if I could factor this, but you can't. So notice that I have the greatest common factor. It's still there. And then I have 3 terms on the inside. If I have 3 terms here, I would have 3 terms on the inside. Number 2. The greatest common factor of all 3 of these terms is simply a 2. And I'm left with a y to the 5th minus y plus 3. That's it in factored form. That's it. The greatest common factor of number 3, they all share an x. I'm left with x plus 1 minus y. Common mistake is people forget that plus 1. If you have 3 terms here, you must have 3 terms here, because if you're going to distribute it back in, you would need to have the 3 terms. There it is in factored form. Number 4, this is an important one because here the greatest common factor is actually a binomial. If you notice, this one and this one share a factor of x minus 4. So x minus 4 is the common factor, and when you pull that out, you're left with 3x plus 7. That's a hard one to do, but that's part of our factoring by grouping, which we'll eventually get to. Number 5, the greatest common factor of these 3 terms is 3ab. That's the largest number and number of expressions that I can pull out. So I'd be left with 5a plus 6b minus 1. A lot of people will forget that minus 1. Remember, you have the greatest common factor and then what's left over. This is a factor and this is a factor. If you multiplied those back in, you go right back to expanded form. So you're trying 6 through 11, and then I'm going to do number 12. So a general rule for factoring is that if you have a leading coefficient of a negative, that you factor out the negative. So notice that this polynomial is in standard form. It goes from highest exponent to lowest, but the leading coefficient is a negative. You should pull out a negative common factor. And that's what we did here. We pulled out a negative 3x. These signs switch. So we're going to do that for 12. There's our leading coefficient. It's a negative. The greatest common factor of these 3 terms is a 2, and I'm going to pull out a negative 2. And I'm left with x squared minus 3x plus 1. So see how those signs switched. If you multiply that back in, you would get exactly that. So remember that. A general rule is to factor out a negative leading coefficient. Your next page is the problem set. The expectation is that you will have all of the lesson, the notes, the practice, and all of the problem set due electronically by 10 p.m. next class. So we'll work on questions you have in class. Everything and everyone must submit PDF. No pictures. Everybody must submit PDF. We're not turning it in by hand. I want you to submit it electronically so I have that record. All right, I'll see you next class.